Alright, guys. So, firstly, we move to an introduction about the titration. Titration is a key technique in volumetric analysis can be effectively applied to the analysis of fruit juices. Titration is a basic method used in volumetric analysis, which is a popular quantitative analysis technique in chemistry. To fully react with a material of interest, a solution with a known concentration referred to as the titrant must be added under strict control. Titration is also a crucial technique for accurately and precisely quantifying chemical reactions, identifying unknown compounds, and figuring out a solid's concentration. Fruit juices are widely consumed beverages around the world, and customer happiness and health considerations are greatly influenced by the quality and composition of these drinks. Fruit juice components such as acidity, vitamin C content, and sugar concentration can be accurately and reliably measured using titration, which also delivers useful information about the fruit juice's nutritional value and flavor profile.
Now I will explain to you what is volumetric analysis. Volumetric analysis is a chemical analytical method that measures volume of reacting solutions. It employs titration to ascertain the concentration of a solution by precisely measuring the volume of one solution required to react with another. In this process, a known volume of a standard solution, the titrant, is dispensed from a burette into the solution of unknown concentration. The reaction reaches the equivalence point when the two substances are present in exact stoichiometric proportion. These are the common titration. The first one is redox titration, the second one is composometric titration, and the third one is acid-base titration. Next, let me explain how acid-base titrations work. First, it involves a neutralization of reaction in which an acid is reacted with an equivalent amount of base. Second, titrant curve pH of the solution versus volume of titrant added. Third, titrant is usually strong standard acid or strong base. Fourth, endpoint is a point when the reaction is completed by changes in the color of the solution. Fifth and the last one, equivalence point is the point of stoichiometric equivalence between the analyte and the reagent. Next part is titration of fruit juice. Fruit juice contains both citric and ascorbic acids. Citric acid is used as a natural preservative and provides a sour taste. Fruit juices are often used as examples of weak acid. The citric acid content of a lemon and orange juice can be determined through a titration of the juice. The experiment will be conducted to determine the amount of citric acid present in fruit juices. This process involves a certain volume of juice having a base of a known concentration added to it until a point is reached where all the acid in the juice is neutralized. Juice made from lemons is the most acidic. It rates between 2.0 and 2.8 on the pH scale, while the pH of orange juice is between 4.0 to 4.2.
Okay, for the next part in methodology is apparatus and chemicals. Apparatus and chemicals that we need to use is beaker, conical flask, retort stand, burette, dropper, 20 milliliter pipette, distilled water, fruit juices which is orange and lemonade, sodium hydroxide 0.1 mol solution, and lastly phenolphthalein as indicator. Okay, next for the procedure. First step is 10 milliliter of the orange juice was pipetted into conical flask, and then 10 milliliter of distilled water was added in the conical flask. After that, 2 or 3 drops of phenolphthalein was added as indicator, and then the orange juice in the conical flask was titrated with sodium hydroxide from the burette slowly while shaking the flask until the indicator changes color. And then for steps 5 is steps 2 and 3 was repeated 3 more times. The endpoint of the titration was recorded, and then steps 1 until 5 was repeated using lemonade juice. And then after that, the mass of citric acid in the fruit juices was calculated. Okay, so this is the example of results from our titration in fruit juice just now. And as you can see, the down below is the chemical equation for citric acid and sodium hydroxide.
Alright, let's move to the discussion. By using this method, we can determine which of the solution is more acidic and less acidic. Orange juice and lemonade juice are used as a sample in this experiment. The reaction between citric acid and sodium hydroxide will form sodium citrate and water. We have determined the amount of sodium hydroxide that is needed to neutralize the acid. The average of sodium hydroxide used to neutralize both orange and lemonade juice are 19.7 ml and 22.7 ml respectively. It shows that the volume of NaOH used for lemonade titration is higher than orange juice. It means the lemonade is more acidic and the pH number is lower than orange juice. We have figured out the total mass of orange and lemon juice that we use in this experiment. The total mass of orange is 0.126 gram, meanwhile the total mass for lemonade is 0.145 gram. There are some precautions that we must follow during the experiment, but the most important steps is to place the eyes exactly at the level of meniscus when recording the burette readings. The eye level must be perpendicular to the reading when recording the data to avoid the parallax error.
Right, so last but not least, we move to the conclusion. So the specific function of a volumetric analysis or titration in fruit juice titration is to ascertain the acid concentration, primarily citric acid in fruit juice. This technique is used to evaluate fruit juices for acidity, which has a significant impact on the taste, shelf life, and general quality of the product. The process is dilution of a certain volume of fruit juice sample plus addition of an appropriate indicator. In this experiment, a burette containing a standardized sodium hydroxide solution is gradually introduced to the sample while being continually stirred. The juice acid and base combine to produce a neutralizing reaction. The point in the titration at which all of the acid has been neutralized is indicated by the indicator's color shift. To calculate the acid concentration in the fruit juice, the volume of sodium hydroxide solution used is noted. Fruit juice titration ensures consistent and accurate measurement of acidity in fruit juices, contributing to their overall quality and customer satisfaction. It also gives crucial information for quality control, product labeling, and also flavor assessment.